Our next questions here talks about volume and talks about mass as well. Okay, but one is of hydrogen and one is of magnesium. So again, we identify what are the formulas we need to use. So based on that, the formulas that we need to use, because they're talking about finding volume, so we definitely need this for gases because we're finding the volume of hydrogen gas. And then they gave us the mass of magnesium. So again, we need this formula. So it's the same two formulas. So let's say we want to find the volume of hydrogen, which is what they're asking us for. We need the number of moles of hydrogen times 24 dm cubed. The question is, do we have the number of moles of hydrogen? We don't have that. So what do we do next? So if we look at mole ratio in an equation, so in this equation here, you see that to produce hydrogen, let's say we have magnesium, and we compare these two, the mole ratio is 1:1. So because of that, magnesium to hydrogen, in the equation, the mole ratio is 1:1. Can we find the number of moles of magnesium first? So number of moles of magnesium is 6 grams given in the question. Divide by the molar mass of magnesium. Molar mass of magnesium, referring to the periodic table, is 24. So molar mass has a unit of gram per moles. So you can write it down if you wish. And that will give us 0.25 moles of magnesium. So if the ratio is 1:1, that means the number of moles of hydrogen will always be the same as the number of moles of magnesium. So therefore, number of moles of hydrogen is 0.25 moles. Once we have that, you realize that I can now put this number into this, where I can find the volume of hydrogen. So volume of hydrogen now will equals to 0.25 times 24. So volume of hydrogen equals to 0.25 times 24 dm cubed, which means what do we get? We get 6 dm cubed. So again, we are always finding number of moles, mole ratio, and always knowing which formulas to use.